Hello. All right. So, for science class, I think a lot of what we're going to be doing is doing experiments and searching for information on our own and drawing our own conclusions and asking our own questions. But I still wanted to give you something to work off of for this first week. So this video should be pretty short, and I'm just going to be running through a quick little presentation on shadows and the ray model of light, just to provide you guys with some background information so that you can do assignments and so that you can be thinking about these things this week. All right, so that being said, questions of the week. So the theme of this first week is going to be around shadows. And so a few questions that I've asked are, how are shadows formed? Why do they even exist? Why aren't they completely dark? Why can we still see things that are in the shadows? When are they the darkest? So what are the conditions where you get like a really dark shadow or maybe a lighter shadow? And what kinds of objects cast shadows in the first place? Like, what makes them so special that they get to cast a shadow? So, moving on from that, we're going to be talking about the ray model of light. So, what this essentially means is that you have some kind of light source. I believe this picture is a little candle, but it could be the sun, it could be a flashlight, it could be something that glows. And light comes from this light source, and it goes out in straight lines. So rays of light, which is what we call the lines, are just going out in all directions, but all in a straight line, right? When light moves, it doesn't go around things. It goes in a straight line, and it hits things. And when it hits stuff, things happen. And that's basically what we're going to be talking about today. So, when light hits stuff, things happen. But the type of stuff that it hits determines what happens. And so there are 3 underlined words that I would really like you to pay attention to today. So the type of matter in an object determines the amount of light it reflects, absorbs, and transmits. And we'll go over what those all mean in the context of talking about the different types of matter. All right. The first one, transparent material. It allows light to pass through it freely. So this essentially means that all the light that hits it is going to be transmitted. And transmitted basically means it goes right through. This means that objects can be seen through the material. So an example of this is clear windows, or glasses, or clear water. Right? The light goes through it so you can see what's on the other side, and you can basically see it perfectly. Despite refraction, which we'll talk about later, but the idea is you can look at it and you can see what's on the other side and you can make out what's going on. A translucent material allows most light to be transmitted through, but it doesn't go perfectly. So there's a note here that light is transmitted, absorbed, and reflected, right? Light is transmitted. Light does get through. You can kind of see through the material. Absorbed means that some light hits it and that light kind of gets eaten up by the object. And then reflected means some light will hit it and bounce right off and bounce into your eyeballs and so that you can see it, right? If all the light was absorbed and it was not reflected, you wouldn't be able to see the object at all. It would kind of probably be like a black hole. But because the light that is transmitted is scattered, you can't see clearly on the other side of a translucent object. So an example is in a lot of bathrooms, if you have a window, the glass will be frosted, which means nobody can be outside and looking through your window and seeing what's going on in the bathroom, right? Other examples of translucent objects are wax paper or tissue paper. And then some types of thin plastic, like if you have folders or lids made of plastic, sometimes they have a translucent finish on them. And here's a little example of our little candle thing. you can see the shadows. You can see that there's something on the other side, but you can't make out the details. And then good old opaque allows no light to get through. Some light is absorbed, and some light is reflected. And so you can't see on the other side of this object at all. An example is a concrete wall, or a brick, or a cat, or a computer. I would say it's fair to say that most objects that we interact with on a daily basis are opaque. We can't see through them because we don't have crazy X-ray vision or anything like that. And so here's a diagram of the rays and sort of what's happening. With a transparent object, the light goes towards it, it hits it, it goes straight through, no problem. We can see what's on the other side. With an opaque object, the light goes towards it, it hits it, it's absorbed, some of it is reflected back into our eyeballs so that we can see, and that's about it. And then with translucent, light goes in, some light bounces off, some light's absorbed, and some light is transmitted, but when it gets transmitted, it gets all mixed up. And so you can't see a clear picture of what's on the other side. Here's another diagram that shows that exact same thing. So you have transparent on this side, light going through, translucent on this side, light bouncing off, some light going through, but it gets bent, it doesn't go straight. And then with opaque, the light's hitting it and then it's just bouncing off. You can't see what's on the other side. Alright, so then what about shadows? So basically, when light hits an opaque object, or even a translucent object, it's going to create a shadow because on the other side, you're not getting the light from the source hitting whatever is behind the object. And so here's a diagram of this. The light's going, it's hitting this solid object, and then it's stopped. There's no light from the source getting into this area, and so it's creating a shadow, which is just the absence of light from the source. And you'll notice here that when it's closer, it's creating a bigger shadow, and then when it's farther away, it's creating a smaller shadow. That's just because a object that is closer to the light source is going to be blocking more light rays than one that's farther away, right? As the light rays are sort of starting out close together and then getting spread out as they go forward. Something closer is going to be stopping more. And so then you might be asking, all right, well, if the light from the source isn't getting there, then why isn't it completely dark, right? Why can we still kind of see in the shadows? And that's because there's usually never just one light source. And even if there is, the light is bouncing off of other opaque objects all around, right? So yeah, maybe the light from the source isn't getting in the shadow, but maybe the light is going up to the top, bouncing off of something, and then bouncing into the shadow. And that's why we can still see, because some light is bouncing off of other things and then getting bounced into the shadow zone. All right. And then this is sort of like a little bonus extra. I don't know if you've ever seen this before, but sometimes you get a dark shadow and then a lighter shadow sort of around the outside. And so you have two basically separate little shadow zones. We have the umbra, which is the super dark part, and then we have the penumbra, which is the lighter part around it. And a lot of the time where you hear this being talked about is in the case of a solar eclipse. Now, I don't know if any of you were there watching for the solar eclipse we had just a short while ago, last year or the year before, I can't remember, but I do believe that we were in the penumbra of the eclipse. So we weren't in the dark part of the shadow, but we were still in the shadow. And that's why, if you were out during that time, you could still see, right? We still had light going on. It wasn't exactly like it was nighttime, but it was still getting noticeably darker. Whether if you were in the umbra, that's when it sort of becomes almost like night at the right part of the eclipse. And that's what I have to say about shadows. There's going to be a little bit of I guess it's an experiment assignment posted that you guys can use to interact with these types of objects and things. And that'll be it for this week for science. All right. If you have any questions, please come to question hour and we can talk about light and shadows and things like that. Okay.